Yeah, good.
Okay, today is, you know what the date is?
The 14th, question mark?
14.
Right.
Did you know
If you
all?
put the date backwards
Long
from
is
this week,
Yeah, if you go backwards, it's the same. 4/14/14.
my birthday's a month.
Did you not get one? I told them to give you one.
That's probably my error. You said pass it. I thought you even pass it to them. You did not say make sure Mr. Beck gets one. You said ship one that way.
I said, make sure Mr. Beck gets one.
You did not say that. That is a false statement.
All right, so today we're going to identify geometric sequences. Now, arithmetic ones had a common difference.
Second.
Not second, first. Had a common first difference. For geometric, it's going to have a common ratio. So you're going to be able to multiply or divide one term by a number to get to the next term. And that number is the same. So if you look at these examples, problem number 1. Is this sequence geometric? They're going from 3 to 6, 6 to 12, 12 to 24, 24 to 48. This is called geometric because they are multiplying each term by 2. So 2 is your common ratio. We use R now, not D. R is 2. So to go from 3 to 6, they multiplied by 2 and multiplied by 2. Multiplied by 2, multiplied by 2. Now, the easiest way to figure out if it's geometric is you take the second term and divide it by the first term. Take the third term and divide it by the second term. So in this case, you see that R is 2. So now I'm going to show you right now, how would you find the next term in the sequence? What would you do? You would multiply the previous term by 2. So that's your recursive formula. This is going to be the recursive formula. You state the first term, which is 3, and to find the next term in the sequence, you take the previous term, which is called a sub n minus 1, and you're going to multiply it by the r value, which is, in this case, it's 2. So if you wanted to find, here I've given you 5 terms, 1, 2, 3, 4, 5. To find the 6th term, you take the 5th term and multiply it by 2.
Shocking.
Now, what if I asked you, hey, what's the 50th term? Are you going to sit there and go multiply by 2, multiply by 2, multiply by 2, no, it'll
Possibly.
take you forever. The explicit formula, so this one's recursive. The explicit for this one looks like this. I'm going to write it above here. You state the first term, and the first term in the sequence is 3. And you multiply it by the ratio to the n minus 1 power. So 3, and the ratio we said is 2. So if I wanted to find the 50th term in the sequence, you take the ratio, you raise it to the 49th power, and you multiply by the first term. That's how you do those.
So the power is always going to be the term you're looking for.
No,
Minus
one
one.
less,
You get a
minus
big
1,
number.
yes. So for B, I just want to know, can you tell me if this is even geometric? They went from 3 to 6, 6 to 9, 9 to 12. They added 3.
No, it's arithmetic.
So this is arithmetic. It's not geometric. How about this next one? This one is geometric. So the easiest way to figure out the ratio, you take the second term, 3 to the 10th power, and you divide it by the first term. And we learned when bases are the same and you're dividing, you subtract the exponents. And do another one. 3 to the 15th power over 3 to the 10th power. This is going to be 3 to the 5th, because 15 minus 10 is 5. So this has a common ratio, and the ratio is 3 to the 5th power. Okay? So flip to the back. We're gonna do A, B, and C. This is just, can you identify whether or not these sequences are geometric? And if they are, I want the first term in the R value. So let's do A. Is this geometric? It is?
Yeah.
Yeah.
Sure.
Avoid deflection, I see you.
It is.
R is 2. Now, what's the first term? That's all they wanted to know. How about the next one? It's not? Why not?
None.
Because you're adding 4.
None.
This is arithmetic, you're adding 4. How about this next one?
Yeah. Yeah.
What's the R value?
2 to the 4th?
And it would be 2 to the 4.
Alright.
That's your R value, 2 to the 4. And the first term is 2 to the 3rd. Okay? Next. Okay, now it's gonna get a little crazy. Now I'm gonna ask you, I'm gonna give you a sequence, 4, 12, and 36, and I'm telling you that it's geometric, 4, 12, and 36. And I want to know what is the 10th term? That's what this problem says. So we start with 4, then we go to 12, and then we go to 36. To find the 10th term, you could easily just keep multiplying each term by what? What are they doing?
3.
R is 3. You could keep doing that.
12 to the 9th.
We're not going to do that. We're going to go into the explicit formula. The explicit formula looks like this. The 10th term, it's the first term in the sequence times the R value to the n minus 1 power. So in other words, 4, R is 3, and then 10 minus 1. So what is 4? And you're going to need a calculator for these problems. So order of operations is do this first and then multiply by 4. You should get 78,732.
32. Yep.
Okay? Now, B is a little different, and they show you a little different way to do this problem. I'm going to show you another way. I want you to look at this formula. I want you to look at this power right here. And can you tell me the relationship between these two subscripts and that right there? What did they do? What did they do? They subtracted them. So now look at this problem right here. They give you 2. They don't give you the second, they don't give you the third, and they give you negative 54. So they give you the first term in the sequence, and they gave you the fourth term in the sequence. Does everyone agree? They gave you the first and the fourth. So now we're going to alter this formula. I'm going to put this number right here. A sub 4 equals A sub 1 times R. What power will this be? What did they do here? We subtracted them. So what's this power going to be here?
N plus 1? No.
No, take these two and subtract them.
Oh,
What's
N
4
plus-
minus 1?
3.
3. Well, what is the fourth term?
54. Negative 54.
What is the first term?
2.
Solve for R. Divide by 2. What's this? And now how would you solve this? Cube root of negative 27 is? So that's what they did. They went down by 3.
That's the other way to do the same problem.
Huh?
That's the other way to do A.
Yes, that's the other way. Yep. So, what would this be? What would the next term be? So you'd have to multiply this by -3, what do you get? Multiply this by -3, what do you get? Multiply this by -3, what do you get?
It's weird. I don't like how it flips between positives and negatives. Makes me laugh.
Right here, if you're missing one term in the middle, the geometric mean is, you take the square root of the product of them. So that's how you would do this next example that's on the previous page.
6.
So you take the square root of the product of these. So what would be, so if we're finding the middle term, what you're gonna do is take 3 and 12, multiply them together, and then what's the square root of 36? That would be 6. Okay? Try problem 4. Try problem 4. Is that here? Sure, thanks. Page is leaving. That back page. Okay, problem 4.
Is it?
Problem 4, and it's done for you. You multiply these two together. What's 48 times 3? Is 144. And the square root of 144 is 12. So 12 is the answer. Okay, how would you do number 4? Got it, 4. It says the 9th and the 11th term. This is the 9th term, and here's the 11th term. How would you find the 10th term? What would you do? Square root of 45 times 80. We had it yet. $45 times 80. 60. And you get 660. Easy? Okay, Brett, turn that off.